If you've been using Sublime Text for a while, you've no doubt run into scopes and scope selectors. They're used all throughout Sublime to provide customizations on things from visual appearance all the way down to the behavior of Sublime itself. And you may have wondered, what the heck are scopes and scope selectors? Where do they come from? What can I use them for? And if so, you're in luck because this video is all about scopes and scope selectors. Hello, fellow Sublime Text fanatics. ODAT Nerd here, and welcome to this video all about scopes and scope selectors. Now, hopefully by the time we're done, you'll have a better understanding of this extremely powerful and useful concept in Sublime Text. Now, before we get started, I'd like to remind you that if you have any questions or comments either on this video or any of my videos, or even suggestions for other things Sublime Text related that you'd like me to explain, leave a comment in the comments section below or ping me on Twitter at ODATNerd. And you may also want to thumb the video if you find it helpful and useful, and subscribe and perhaps even use the bell notification icon if you'd like to be notified when new videos become available. But let's start off our discussion on scopes and scope selectors by looking at some examples of them that you may have come across while working with Sublime Text. And I've gone ahead and set up some files for us to look at to get started. So the first thing we're going to look at comes from the Preferences settings file. And this is just a small cut down excerpt of that file for the sake of brevity, since there are quite a few options in there. And I've also turned on word wrap so we can make sure that we can see all of these items. And these are three items that use scope selectors. Now, the first of these is spelling selector, and this controls the places where spell checking occurs. If you've ever wondered why spell checking occurs for comments or strings in your code, but not in reserved words, this is the setting that controls that. And this scope selector here looks pretty long and complicated. The next setting here is the autocomplete selector that controls places in your files where the autocomplete window will automatically pop up to provide you completions, assuming there are any. And this is a much shorter setting than the previous one, and it's perhaps still a little complicated. We might not know what that means. And this third example is the autocomplete triggers, which uses a given selector, as we can see here, of text.html. This controls other situations and other characters that cause the autocompletion panel to pop up in addition to the completions automatically opening as above. And this is using a scope. This is the smallest and probably the most common type of scope you might be familiar with. But what exactly is this doing? And we have another example here. This is a Sublime build file. This is the Python build that ships with Sublime. And just as a note, I'm using package dev as add-on package. And so as you can see in the bottom right of the window, this uses a different syntax than you might see otherwise, which is why I'm getting more syntax highlighting here. Standard Sublime just uses the JSON syntax. But what we're saying here remains the same. And we can see down on line 4, there's this line that says selector that says source.python. And what that's doing is telling Sublime that if it needs to automatically select a build system, this is the one to pick for Python files. But where does that source.python come from? And here's another file type that you might have come across in your travels in Sublime Text land, a snippet file. This is an XML file. Well, we can see right there on line 3, there's a tag that says scope. This also says source.python. This is telling the snippet that it only applies to files of type source.python. So this snippet won't trigger in an HTML file, for example. And the confusing thing here is in this file, this says scope, but in the previous file, it said selector. What's up with that? Now, although we're talking about scopes, all of the examples I've shown here and many other things that appear in Sublime that we're not talking about just at the moment, these are all scope selectors, and they're being used by Sublime to literally select, based on a scope, what situations various things can or should occur. But what does that actually mean, and how does it actually work? And in order to get to the bottom of that, we first have to talk about what a scope actually is. Now, a scope is simply a string that provides information about each and every character in a file. And it consists of a space-separated list of one or more dotted strings that specify, from the least specific to the most specific, the layout and content of your files in Sublime Text. One thing you can do to view a scope in Sublime is to go to the Tools menu and look under Developer Show Scope Name, or use the appropriate key binding, which for me is Control-Alt-Shift-P. On Mac OS, this will be a slightly different key, but if you use that menu item, you'll be able to see it. And when you choose that, this HTML pop-up appears to tell us what the scope at the current cursor location is. Now remember that I said that a scope is a big long space separated string. This is actually one string with spaces between each of these three lines, but to make it easier to view, the scope display pop-up is separating it line by line. So instead of one long wide window, or one long wide pop-up the width of the entire window, we get to see it more laid out. And it's also worth noting that even though this is in the tools developer item, this isn't something that's really for developers only, because as we'll see in the next video, you sometimes, even as a non-developer, need to know scopes in order to be able to make the modifications and configure Sublime the way you want. And that's what this allows you to do. And this is the example of the scope at the first character position, but I could jump down to here and press that same key binding and get a different scope pop up. Now, this isn't standard Sublime, but since we're going to be talking a lot about scopes and I don't want to keep hitting that key binding all the time, I went ahead and created a plugin to help make this a little easier. And so if I go into the command palette and pick toggle scope display, as you can see right there, this plugin displays this green line and then that same information that we saw in the pop-up at the bottom of the screen. And it updates as we move through the file, allowing us to see the scope without having to press that key all of the time. And for the rest of this, we're going to jump over to this C# source file to provide a little bit more information. And I've gone ahead and enabled the plugin in this already. Now, as I move the cursor through the file, we can see that the scopes are changing based on, of course, the cursor location, because that's what scopes do. And there's some lines have more scope information, some lines have less scope information. And so there's a lot of information conveyed here, but the information that we're seeing falls into two general kinds of information, or two different categories of information, if you will. And those two items are specificity and hierarchy. So note that no matter where we look in this file, the scope always starts with source.cs. And that's telling us that this is a source file as opposed to a text file, because this is source code, and that more specifically, it's a C# source file. And note that the scope doesn't need to follow the actual extension of the file. If I was to, example, jump over to this, we can see in the Python file, the scope is source.python and not source.cs. This is a decision made by the people that create the syntax highlight, and we're going to be talking about that in just a minute. I'm mentioning that because sometimes it can be confusing and you think that a scope has something to do with the type of the file that it's associated with, and that's not really the case. The only important thing to note is that all source code type files will have a scope that starts with source, and whatever comes after it is unique amongst all of the syntaxes that are currently installed. Any specific single scope element, which for our purposes is one of the white lines at the bottom, these provide information about what that character is for with increasingly specific refinements. And the more dotted parts there are, the more specific that particular scope element is. And in addition, the more scope elements there are, the more specific the scope as a whole is. Now, let's notice that there are three different styles of comments in this particular file. They all contain a scope element of type comment, although potentially in different positions. But apart from that, this one is marked as a line comment, while this one is marked as a block comment. And not only is this a block comment, but it's a documentation block comment. So as each of those parts of the dotted scope portion appear, it adds even more specificity to that particular type of item. This is a comment, this is a line comment, this is a block comment, this is a block comment of type documentation, and in this case, this is a comment that is the block comment that is specifically a documentation block comment. And most specifically, it is a C# documentation block comment. The other thing I mentioned was hierarchy, and we've already witnessed this to some extent, but we'll note that if I bring the cursor up to this line that opens this class, we can see that the scope is telling us that this is a meta.class line. And as I move downwards through the file, the meta class scope becomes meta.class.body, telling us that this is the body of the class. And it's outside of the body of the class, that scope is not there. But inside the body of that scope, of that class, that scope is there. We can also see that even though these all have a scope of comment, that meta class body scope applies to them as well. So we can see that this is sort of providing us a sense of hierarchy as well. And if you can imagine this as a tree structure, that would allow Sublime and thus us to roughly know the structure and layout of the file. Because as we can see, this is a comment that's inside a block, that's inside a class, that's inside a source.cs file if we read that scope from the bottom up. This comment is just a comment in a source file. It's not in a block. Now this raises the question, where do scopes actually come from? And the answer to that is that scopes are applied by the syntax definition that's in use in the current file. The syntax definition provides both a set scope that applies to everything within that file, which in our case is the source.cs that we see here. And also, it contains a series of rules that allow it to determine how the file is structured. And of course, those rules depend on the language in question. Now, this means that scopes can and will be different to some degree between different types of files. And that means they can be really explicit or particularly scant, depending on the quality of the syntax definition that's in use, and also to some degree, the complexity of the language as well. It's hard to come up with a lot of complex scopes for a very simple language, for example. Now, there are guides for the syntax authors to use that helps to ensure that similar constructs in files are scoped in similar ways. And an example of that is the comment scope we see here. What follows as the specificity of the comment scope may be different from syntax to syntax, but anything that's considered a comment should be scoped as a comment. And that allows us to ensure that even though there may not be a lot of really specific scopes, or maybe there are, the scopes that do exist still mean the same thing as we go from file to file. What are scopes actually used for? Well, we saw just three examples at the start of the video for controlling when auto-completion happens, or for controlling Sublime build files when builds are supposed to happen, or even when snippets are supposed to happen. But they really Our scopes are used all over Sublime. Perhaps the prime example of that is color schemes, which use scopes in order to determine how to render the actual code in the buffer. And another would be key bindings. If you've ever wanted to create a key binding that only triggers in certain files or in certain places in files, scopes are a way for you to be able to accomplish that. And of course, as a plugin author, particularly if you're trying to interact with a file of some sort that's already open, scopes are great for being able to help determine the structure and navigate around inside of a file. Now that we know what a scope actually is, we can circle back around to what a scope selector is so we can better understand what those examples we looked at initially were doing and how they work. Now, visually, a scope selector looks more or less the same as a scope does. It's still a space-separated set of dotted strings that provide specificity and hierarchical information. And there are some extra things that scope selectors can include that scopes don't, but we're going to talk about that in just a second. Now, the big difference is that while a scope provides all of the information that's available for every location within an open file, a scope selector is for actually using that information for something. The things that we saw in those first three files in the preferences file, in the build file selector, and in the scope in the Sublime snippet file are all examples of scope selectors. There are a few things that you can actually do with a scope selector. And the first of those is matching. And this is perhaps the most obvious use case for a selector to be able to determine if a particular point in a file matches a particular scope. Now, an example of that would be a snippet. The snippets contain a scope selector and that determines in what situations it can be expanded. So Sublime behind the scenes is constantly checking scope selectors in all snippets against the current cursor location scope so it can see if that location has a scope that matches. And if it does, that snippet can be expanded there, and if it doesn't, it can't. And if you watched my video series on the Simple Notes plugin, you will have seen that our plugin used a scope selector match to know if it should provide completions or not by matching the scope at the current cursor location, which is a code version of the exact same thing. If you haven't seen that, there's a playlist that you can view on the channel. Now, that same plugin example also includes another use for scopes, which is to find all of the places within a file that a scope selector actually matches. In the case of that plugin, that was used to find and extract all of the note tags from the current file so they could be displayed for the user to pick from. And along with being able to find matches, it's also possible to do something with scopes called scoring. And this is used in situations where multiple scope selectors might match and you want to know which one of them matches the best or perhaps the worst, depending on what you're doing. An example of that Sublime does on its own is in color schemes. Now, color scheme can provide a set of scope rules that say what colors and font styles apply to a piece of text based on the scope that it has. And the color scheme can have multiple rules that might match any particular location. So the highest scoring match is the one that would be used. And that allows you to do things like, say, make comments in some files a different color than in other files. And color schemes in general are a pretty big topic, so we'll see some more about that in the next video, and we're not really going to discuss it too much here. But scoring might also be useful to you if you're working on a plugin of some variety. Now, at this point, this perhaps maybe doesn't make total sense because we've talked about what scopes are and what a scope selector is used for, but we haven't shown any practical examples of that. So let's go ahead and do that now. Now, it stands to reason that if a scope selector is for comparing against a scope to see if it matches, or in the case of scoring, how well it matches, scope selectors probably don't need to be nearly as explicit and complete as a scope is. And think about this logically. In a regular text file, are you more likely to search a file for all of the occurrences of a single word or all of the occurrences of an entire paragraph? You probably want to use less granularity and dial in as needed. And so, in fact, a scope selector can be similarly as minimal or as explicit as you might want or need it to be, depending on what you're doing. And that's where the real power lies. In order to demonstrate scope selector matching, I've created a simple plugin that accepts a scope selector and then visualizes the results of what the scope selector matches by marking it up with regions in the file. And just as a side note, if you're interested in how this plugin actually works, if keep your eyes peeled for an upcoming video, I'm going to go ahead and demonstrate how it was written and how it works. And there's a lot you can do with scope selectors. So let's start simple and work ourselves up to the more advanced options and techniques that are available to us. Let's start things off with a simple match. Now, a simple match is just a single scope element, which may be dotted if needed or desired. And for a lot of cases, this is probably the sort of matching that you'll come across. So we're going to match on source. And we can see that this matches this entire document because the first scope element throughout the document is source. If I go over to the Python file and do the same thing and search for source, it also applies here. But in the text file, no matching scopes are found. And that's because the main scope is text.plain. And by contrast, here's another thing we can try. Source.cs, where I'm adding specificity to our scope selector. That still matches here in the C# file. Here in the Python file, if I add .cs to the end, it doesn't match anymore because although this is a source file, it's not a source CS file. And as you might expect, if source doesn't work in a text file, source.cs isn't going to work either. Now, you'd see simple matches like this in places like build systems or snippets, because those are generally trying to constrain things to just a certain class of file or a certain type of file. For example, the Python Sublime build system would use source.python because it doesn't matter where in the file you are building, as long as it's a Python file. And you don't want to use the Python build to build C# code. That's unlikely to work. Now, to add some power to our matching abilities, we can add in the ability to do descendant matching, which you may be familiar with if you're familiar with CSS. Let's search for the scope comment. And like the source example we tried previously, this is just a simple match that finds everything that's scoped as a comment. So it's found all of the comments. If I jump to the start and type meta.class in front of that, this adds a descendant clause, and that specifies that we want to find all comments, but only those comments that are also inside of a class. And so that comment on line 2 is no longer found. And as you might expect, each scope element that you use can be as specific as you would like. So if we do this, we'll only find line comments that fall within a class. And so the 2 block comments go away. Now, building on the power of scopes and matching, we can apply addition to match more than one scope at a time. And this uses a comma to specify items. Think of it as being a list of scopes that should match. So if I say comment.line, you've seen this before. This matches all of the comments that are line comments, so there's nothing new going on here. If I add this to the end, we're adding a comma and specifying another scope selector, and now we can match multiple items. Now, in addition to finding all of the line comments, we're also finding all of the strings as well. And again, as you might expect, each scope selector can use things we've learned previously. So here we can find not only every line comment everywhere, we can also find strings, but now the string matches are constrained to the strings that appear inside the class. So that string on line 14 won't be found anymore. And of course, where there's addition, there's also subtraction. And this allows you to remove items from consideration that might otherwise be matched. Now, if I do this, this is going to find all of the text in the buffer with the meta.class scope applied to it, which gives us the entire body of this class. And of course, if I did this, it would match the exact same thing as it's currently matching because source.cs is part of the scope. But if I add a subtraction operator in here, now by using that, we're say that we want to match everything of type source.cs in the file except anything that's a class. So now instead of selecting the class, we've selected everything that's not the class. And of course, more than one subtraction can be used at a time. So we can also exclude from the file not only all of the classes, but all of the comments as well that might otherwise have been found. So now we're just finding the empty line at the beginning of the buffer and all of those lines at the end. And as possibly the most contrived example we've seen thus far, after redacting all of the comments from the file, we can also use the addition we used previously to add comments back, such as adding in the documentation comments, regardless of where they match. Along with what we've already seen, we also have the ability to use Boolean operations of and or with our matches. And this allows us to be more expressive with our matches and perhaps achieve things we might otherwise not be able to. And as we'll see in a second, it also enhances readability of your scope selectors quite a bit. And as we've seen before, we can use the comma to add matches together. So if we do this, we're finding all of the block comments and all of the strings. Another way to write the same thing is to use the Boolean OR operator, which is a vertical pipe if you're not familiar with that concept. This matches the same things that we just saw, but it looks a little bit different. So why is that useful? Well, let's say you want to find all the block comments and all of the strings that appear inside of a class. Using what we already know, we can easily craft a scope selector that does that using addition, but it's a bit long and it's a bit redundant. It's specifying that meta.class twice. We can use a Boolean AND, which as we can see is an ampersand, much like we did with the OR above. This scope selector is less redundant because it only specifies meta.class once, which helps readability and maintenance. And this also demonstrates that you can use parentheses to group match components together, which is also good for clarity, but also helps you to avoid potential ambiguity and can also make things easier to specify. So this is saying that block comments and strings should match, but only if they also match meta class. And as we can see, that has the same result. Now that we're armed with more information on how scope selectors work, let's go back to those examples that we started with initially and see if they make more sense now. So now, when we look at spelling selector, we can see that it's a list of multiple scope items separated by commas. So right away, we know there are going to be several places where spell checking is enabled. We can also see that some of those entries apply to source files, one in strings and one in comments, but subtraction is being used to adjust the list. For example, this says that everything in quoted strings contained in source files should be spell checked, except for the parts of the string that are punctuation or part of a preprocessor include. This last item in the list is a negation saying that it matches everything except the items in the parenthesis. This turns off spell checking in source files generally, as well as in scopes that are likely to appear in source files. And this is another example of using parentheses to make things clearer without having to add a minus sign against every one of those items in the list. Notice that the text scope doesn't appear here, so spell checking is automatically enabled for text files. And if I was to take this scope and plug it into our little plugin in the other window, we could see exactly what points in a C# file spell checking might be enabled. And spell checking is enabled in comments and strings, but not in reserved words or in the general part of the body, which is probably what we might expect. Here we can see from the looks of this scope selector, autocompletion happens automatically for tags, but not in the punctuation that defines them. And similarly, it's also defined in source files, but not in comments or certain kinds of strings. And the text scope isn't specified here at all. And there are no exclusions, so autocomplete never automatically triggers for text files at all. And again, we can go ahead and plug this scope into our plugin in the other window to see exactly where auto completion might be offered. And it's not going to be offered inside any of the comments, but it will be offered inside of the code, including inside of the strings. Now, the example of the autocomplete trigger for text.html or the Sublime build of source Python or the snippet using a scope of source Python, those are easier things to think about because we can match in our heads exactly what those things mean. They're just file types in general, regardless of where in that file you are. Hopefully, I've been able to shed some light onto the mystery of scopes and scope selectors, just a little bit. These are a powerful, powerful concept that allows us to customize the look and feel of Sublime Text to get things dialed in just the way you like it. Now, in the next video, we're going to go into some more concrete examples of the sorts of things you can do with scope selectors in snippets, completions, key bindings, and of course, the holy grail of all scope uses, customizing your Sublime Text color scheme. Until then, remember to stay sublime.